Yeah, good morning. Yeah, I told about in the last lecture. I told about some of the tools. Okay, that is some of the lean tools. One is 5S, continuous flow, Aizunka, Judoka, just in time. These tools I explained in the last lecture. So today we'll see some more tools. Yeah, we'll take Kaizen. Kaizen, of course, one of the important tool in lean manufacturing, that is continuous improvement. Okay, you can say it in the beginning, you can say it, do it again. Mhm. Continuous improvement. Okay, how they go about to see it. This continuous improvement can start at any phase. You can see the sketch here. When they're going to celebrate success, means after everything is done as per their requirement. So certainly celebrate success. If it is failed, okay, if it is failed, then do it again. Okay. So that's the last step. Celebrate success. So we start here. That is, you can say it. Document reality. Okay, what exactly now? Right now, document reality, where you are right now, and then identify the waste. To do some improvement, we should know where to start, which improvement is supposed to be done. Okay, so first of all, that is identify the waste. Next, develop countermeasures. That is how to resolve that. Okay, develop countermeasures. Is the change real? Okay, it's very important. Whether it's a genuine, whether really you are doing changes for countermeasuring, and make changes and verify the change. Okay, when you make a change, however it may be, how much it may be small variation or it may be a leap or change. So you make changes, then verify the change, then measure results. Okay, you know that what was previously like, and what is the current now. So measure the current result. Now we establish as a standard now. So once you measure the results, then that becomes the standard. So establish as a standard. Now celebrate success. So lightly they are given picnic. So means of course like celebrating the success story. So you have achieved this one. So let us celebrate. So that's how normally people going for changes. So we can say it improvement, continuous improvement. So continuous improvement, one more term is Kaizen, a Japan term. Kaizen, it is continuous improvement. Okay, start from the document, identifying the waste, developing the countermeasure. So finding the change, make changes, verify it, measure results, and set it as a standard. That's how that they do continuous improvement. Next, how does Kaizen help? Okay, how does Kaizen help now? As a lean manufacturing tool, if you want to identify the waste and you want to continuous improvement, if you want to go for a performance improvement and all, or productivity improvement, how this Kaizen, this continuous improvement going to help? It helps in making, assigning responsibility or segregation of duties. Okay, assign responsibility. See that for any defective quality or any waste in the organization, it is not arised from one person. It may be from different persons across the processes. Maybe that procurement division might not have that bought that a good quality raw material, or maybe that design persons, they might have not done the exact specifications, design specifications. Okay, or maybe that machine might not be maintained properly. Okay, not tuned properly, or the tools what they're using may not be fixed properly, or that processing might have not done properly. Okay, or the quality department may not have done their duty correctly in terms of measuring the quality and all. Or we can say afterward, packaging people or handling people might have not done. So when the customer say this product is quality defect, there's a defect means it not necessarily done by one person, it may be across. So that's why it's very important. If you want to achieve continuous improvement, so you have to assign responsibility. Okay, and also segregation of duties. Okay, this duty should be segregated. So, the culture helps in making assigning responsibility or segregation of duties. Second, it helps in providing strategy where employees work together proactively to achieve regular incremental improvements in the manufacturing process. Okay. It is expected that there should be some regular improvements. Okay. Or there should be some incremental improvements, not necessarily a leap improvement. Okay. So you can't expect any organization or any worker or any individual to show so much of a leap improvement in a single step. So there can be some sort of incremental changes or improvement. So basically this Kaizen helps in providing a strategy where employees work together. Okay, because I told that so any defects or any quality is not attributable to a single person. So there will be many number of people there. So they have to work together proactively. Okay, remember proactively or reactively. Reactively means what? It is after the problem arises, then they are going to correct it. Okay, that is reacting to the problem. Whereas proactive means before. Okay, in anticipating. So chances that this may lead to defective product. Okay, this may lead to wrong manufacturing. Okay, so this may lead to poor processing and all. So in anticipating those, so they are going to act proactively. So they help in providing strategy where employees work together proactively to achieve regular incremental improvements in the manufacturing process. This is the second use of Kaizen R is going to help the organization by providing the strategy. Second. Thirdly, it helps in eliminating wastes. Okay, so how this continuous improvement would help the organization eliminating waste? That is, combining the collective effort of the employees of a company to create a continuous process of eliminating waste. Okay, collective effort. So I told, okay, so it is, we can't blame a single system or single section or single unit to take responsibility of any defects in the organization. Suppose the procurement department not procured materials or equipments or machineries properly, then that may lead to the quality problems in the next stage. So we can't blame only one department. Okay, we say when the part manufactured, we can't simply blame that manufacturing division which is manufactured a defective product, because that may lead to the wrong processing, wrong procurement also. So there is a need to have a collaborative effort to improve the quality or to reduce the waste. So basically this is a continuous improvement being a collaborative effort, combined effort of the employees of a company to create a continuous process of eliminating waste. So there will be a continuous improvement or continuous effort to eliminate waste through collaborative effort. Okay, it's one of the help of continuous improvement. Next, Pokayuk. So one more important term, a Japanese term people normally talk about Pokayuk. That is mistake proofing. Okay, mistake proofing. Pokayuk. Okay, mistake proofing. Pokayuk. That is ensure that the process is error free and stays that way. Remember, this should continue. Okay, start only eliminating the errors, identify errors, and resolving it. Start like that. Okay, so it ensures that the process is error free in future also. Okay, they are going to make a foolproof such that in future it's going to be totally error free. It won't reoccur. You can say reoccur. So ensure that the process is error free and stays that way. Make the process in such a way that it is impossible to make errors. So remember here, when the system made foolproof, so that even if the people try to make errors, it won't allow you to make errors. I give a best example. I think you know that traditionally it is a plug-in of electrical plug and all. So normally, if you're going to switch on and start put the plug in, then you get some sparks coming out of the plug, right? No. So because it's not foolproof. Nowadays they made such that. Okay, one more thing also happens. Suppose by mistake, if a kid or somebody by mistake, if they have some iron piece or something like that, they're going to insert in that hole of the plug, then it shocks. Now you can see that the plugs have come in that it's totally look like a closed one. Okay, unless you're going to put the plug or operate one of the hole, plug won't fit in fact. Okay, it's totally foolproof. So it won't be. So even if you're trying to do that also, shock won't be there. Okay, there won't be something called sparks won't come. Okay, so foolproof. Such that, so when they want to make a Pokayuk, means foolproof means it is even if they're trying to do some errors, should not be possible. It is make the process such that it is impossible to make errors. It is a foolproof. Second thing, it is use low-cost ways, reliable devices, or innovation for preventing or detecting errors by people or system in a process. Remember, just to make a foolproof, you can't go for spending lot of money for it. Okay, so remember, any system you are developing for foolproofing should be of low cost. Okay, develop a low cost system for foolproofing and also reliable devices. Remember, when you want to make totally error-free system, even if they are trying to do errors, you should make sure that it's impossible to make errors. So when you want to do that system error-free, the device also should be reliable. Okay, so it's very important to use reliable devices or any innovation for preventing. Okay, innovation for preventing or detecting errors by people or system in a process. Okay, so that's very important. So make sure that so it should be error-free by using low-cost ways and reliable devices and some sort of innovation for preventing or detecting errors by people. Okay, remember, so errors may occur, but you should have some device to identify or detect the errors. Okay, by a people or a system in a process. That's what called as foolproof. Okay, how does Pokayuk help? Okay, so in lean, because Pokayuk is one of the lean tool, how this Pokayuk helps in improving the performance of the organization or improve productivity of the system. Okay, so how it helps? It helps in eliminate waste of defect. Remember, so defect is one of the waste. As I already told you in the previous lectures, that is 7 wastes. Okay, So it helps in eliminating the waste of defect. It helps in detecting and preventing the occurrence of defects in the process. So when you develop a foolproof process, then even if you're trying to do errors, it's not possible to do. It's impossible to make any errors. So certainly, when it's not possible to make any errors, then any component or a product coming out of that process is also error-free. Okay, so when there is error-free, nothing but it's totally defect-free. Nothing but there is no wastage due to defects. Okay, zero defect. That helps in detecting and preventing the occurrence of defects in the process. Second, it helps in manufacturing process. That is, it helps in detecting defects in products and prevents their further processing. Okay. When the process is made foolproof, so certainly entire manufacturing process also becomes foolproof only, so that there won't be any defects. So it also is going to provide a system such that the defects can be detected by a person or system easily. So POCAC is such that it's going to provide such that any defects going to occur, it can be detected and also prevented easily. So that won't help in manufacturing process by detecting the defects in product and prevents their further processing. That's how that the POCAC helps. Yeah. Next, one more important tool, that is value stream mapping. It's the core of lean manufacturing. Value stream mapping, because what we call as elimination of waste and reduction of lead time, improving profit. Okay, all these things are basically meant for improving the productivity. Okay, so maybe the flow should be avoided so that we can reduce the lead time also. We should differentiate non-value added and value added items, and remove non-value added items because they're not going to give any value to the customers. So basically this value stream mapping that takes care of all these things. It's VSM, value stream mapping. You can say typically one of the template format, or you can say some template type of thing is there to show that how value stream mapping works. Okay, I'll let you know all the symbols they're going to use in value stream mapping and all while drawing. Basically, this value stream mapping involves drawing or showing the flows, the organization, from converting from raw material to the end product. It under so many processes. So we need to show all the process involved, ultimately to reduce the lead time and remove the waste or detect waste. So let us say here, so for example here, the customer request has come here. Okay, customer request has come here, and there are going to be some office here that take care of the orders and all. So ultimately customer is given. So for example, they have given an example. It's not clear there. I will show you here. Yeah, business loan approval, value stream map. Okay, so it's a value stream map drawn for business loan approval, value stream map. Okay, so here at the start, there's a customer request for a loan. Okay, from here to here to check the caliber or to cross check once again here. And also you can say that these dotted lines indicate that information is going to flow. Normally, in the value stream mapping, there occurs two flows. One is material flow, second is information. Material flow shown using lines, whereas the information flow shown using the dotted lines. So here documents process here, documents process from the customer. Customer requested so much of documents to show the eligibility of the customer. Okay, so government comes here, it goes to the various sections, going to that system. You have a corporate office, it also undergone. So from here once again they send the documents here to all these things. Then they send information to the system and then send it to the list level. And then they're going to say that eligible, and then you can say customer approved loan. At the end, the customer getting loan here. So these lines indicate that the documents have been moved from one place to another place, whereas dotted line indicates the information going to flow here. Okay, that's how that customer got approval for the loan. Okay, some customer request here, move documents and all. Okay, that's what typically a small example that how value stream works. Okay, so you can say value mapping, material and information flow mapping. Okay, so here basically in value stream mapping, so we are going to map two things. One is the material and second information. It is commonly used in manufacturing, healthcare, software and product development, logistics, supply chain and service industries. We can say more or less this value stream mapping can be applied to all the areas. They're going to be manufacturing or process industries or service sectors. It can be applied anywhere. So you can say, but commonly used in manufacturing, healthcare, software and product development, logistics, supply chain management, and of course service industries. A very simple value stream mapping for accounts payable process. Okay, it's what shown on account payable process. Small format is shown here. Okay, indicating that how things are moving, how much time involved. Okay. Yeah, a value stream mapping for accounts payable process. Yes. So it's the same, similar manner shown. That is the blank approval, loan approval previously. Okay. So here starts. You can say entering invoices and then match invoice and purchase order and receipt. Then authorize for the payment and resolve mismatched invoices, suppose anything are there. So remember here, very important that allowing the activity, the duration also involved here. How much time it takes to perform that particular activity. Okay. So same thing happens in manufacturing also. We got it as a cycle time, lead time and all, but here, so it's an example for accounts. Okay, so wherein you are going to show that the invoices. Okay, that is entering in invoices, it takes 3 minutes. Then match invoice and purchase order and receipt, it takes 1 minute. Okay, authorize payment, so 1 minute. If there is any mismatch there, resolve mismatch invoices, it takes 50 minutes because it requires lots of cross verification and invoice and supplier and auto voucher and all these things are coming to this authorized payment. Then check it once again and then cut checks and mark supplier 2 minutes. Okay, so these are the typical way of showing. Okay, showing the process flow and time involved in performing that particular activity. So here I have shown a few of the icons used in mapping. Okay, so value stream mapping should be drawn using some typical icons. So can't be drawn as you like. It's not a block diagram. So when I want to use a triangle for storage, a rectangle, and square for inspection and all those things. Okay, it's not. Okay, so here it has got some typical icons to be used while drawing value stream mapping. So say for example, if you want to show the factory or anything that is external organization, so this icon should be to be used for factory and all. Raw material enters in, raw materials move to this factory. So any factory items, okay, that you can say external organizations normally shown like a factory. This is what typically they show this structure as a factory. So external organization. Then processing here, okay, normally first block, okay, this is a processing block. What happens? Converting raw material to the semi-finished or this thing and all, okay. So for example, crude oil transport from the harbor went for some sort of processing and all. So these indicate that process blocks, okay, what processing is going to take place at the next stage. Next, the work in process, WIPs are shown like this, triangle, okay, WIP, and in box are shown where data is stored, and push arrow, okay, normally, so we're talking about push system and pull system and all, okay, so show arrow towards, moving towards, okay, push arrow, and material receipts and shipments, okay, material receipts and shipments are shown using arrow marker. Manual information flow shown like this, okay, it is manual information flow, okay, anything that sent through manually. So electronic information flow, okay, showing like electric this one, okay, electronic information flow, this one like this, and operator and employee shown like this. Normally they don't show like eye type, okay, human eye. So that's why the operator or employee, okay, operator O or operator employee is there. And next to go see scheduling, so you can say it aspects has been shown here. Okay, that is to go see scheduling. And movement by truck, a truck is shown here, okay, with the wheel. So that is movement by truck. Normally, in logistics, how the materials have been moved, okay, transported from place to place, okay. Shipment is going to be through roadways or railways or waterways, okay, those things. That's why it indicates that things have been moved by truck. So they are the some of the basic icons of icons used in drawing value stream mapping. So one more important, remember here, one important aspect here, that is, it's very important here, we are going to show that. So we are going to show everything in a systematic manner like this. So we have external organization, materials comes in, raw materials comes in, okay, maybe loaded by truck and all, then undergone so much of processing at various places. So we are going to show here all these things. Data block, sorry, I forgot to tell you, the data block, where you are going to show the processing time, changeover time, 2 shifts, tag time. Okay, those things are shown in the data block. Okay, what are things are shown? Okay, sometimes there won't be like a processing time and all. No, they won't show and all. So suppose there is only one shift, not necessarily show, but you can show that also. So processing time, changeover time is not there, then this won't come on this. So this data block basically showing all the times. Okay, processing time, changeover time, shifts, number of shifts, 1 shift, 2 shift, 3 shift, and tag time. And it's data block. Okay. So let us say here, this is very important because when you're going to draw current state value stream mapping and future state value FSM and all, so you have to show these things: lead time, hours and all, and then processing time, minutes and all. So this, suppose the time is even that lead time is also can be shown in the number of minutes also. If lead time is very less, not shown in hours also. Normally, when you're going to have total, so they won't show in terms of number of hours only, 1 hour, 2 hours, 5 hours, 10 hours, something like that. Because it takes lots of hours only. The means it becomes in terms of thousands. So better show lead time using a number of hours only. It's what the typical way of expressing the value stream mapping. Okay. Yeah. Now that as a lean manufacturing tool, how this value stream help? Okay, value stream mapping VSM helps in improving productivity. Okay. Just go through it. It helps in mapping the flow of the process. Okay, I told these two things. It is current state mapping and future state mapping. So it helps in mapping the flow of the process. Mapping the current state. Okay, what is the existing now, current state of, okay, how much time the system takes for processing at each stage? And what is the changeover time? What takt time? Those things should be shown for the existing one, okay, current state mapping. So then you are going to draw one more, that is the future state. That is by changing the flow or by modifying the layout or by reducing the non-value added time and all. So we can change, okay. So you are going to get a different value stream, right? So it is called as future value stream mapping, future state value stream. So this basically, this value stream mapping helps in mapping the current and the future state of value stream. Second, it helps in streamlining the process. Okay, streamlining the process. It's very important. Okay, any process should be streamlined. Just like they say SOAPs, no? It is standard operating procedures. Same way, the processes should be streamlined. Okay, streamlined. So this VSM, it helps in streamlining the process. It helps you quickly visualize your entire process, identifying bottlenecks where the processes can be streamlined or improved. Okay, because when you're going to visualize everything on a big drawing sheet, say for example, you're going to visualize all the things in a bigger drawing sheet. For example, when the raw material comes in, what are the processing it are undergoing? Okay, maybe drilling, milling, threading, all the operations, how much time it takes, how much time is for changeover, how much time is going to wait for next workstation. Okay, those things, so you just draw everything on a big drawing sheet to show the current state. Okay, current state. Then you understand that how the process is doing now. So now you have to think about, can you change anything here? Can you identify that, or you have to identify some of the non-value added items here. Okay, there may be chance of unnecessary movement, or there will be sometimes during processing, so it may have to go there and it has to come back once again. So it leads to loss of, it may lead to extra movement of the material or even worker. So sometimes because of non-leveled or the leveling is not done properly, then you end up with lots of time waste. So in a FSM, you can identify all these things, you can draw. Surely you can save some timings, or in midterm you can also save some waste and also can improve profit. Okay, so this streamlining the process visualizes the entire process. Okay, it's going to visualize entire process. Identifying the bottlenecks. Okay, there are sometimes, but a particular bottleneck operation that may lead to so much of complications. So, for example, before going for one operation, there may be some important operation that should be carried out. So they don't have facility for it. Then after, so this WIP is going for somewhere else, okay, maybe summer workstation or it's maybe far away, okay, and it has to be, that operation should be done from there only, then it has to come back here, and then they have to start. So imagine that if that transporting item to complete one operation, if it's going for outside, say 10 to 15 days, then that extra waste 15 days. So when you say that you're going to calculate lead time, so if it's going to be around 20 days for a single product, then 15 days has gone for this only. Okay, so it's very essential that to identify the bottleneck. When you're going to streamline the operations or the process, you have to identify the bottleneck. So this value mapping, when you're going to visualize the entire process, you can identify the bottleneck. Okay, where the process can be streamlined or improved. Okay, because when you focus on the bottleneck in the operation, then you can improve it or you can streamline it. Okay, so it's very important identifying the bottleneck. And lastly, this value stream mapping, it helps in identifying the wastes. Okay, it's essential that when you're going to draw FSM, future state mapping, then you should know that what are the areas you can improve or where you come across the waste. So you have to identify the non-value. I told you already, non-value added. So value stream mapping helps in identifying eliminating waste. It provides a roadmap to find the non-value added activities or waste which can be eliminated from the process. Okay, so by clearly distinguishing value added and non-value added, and by removing non-value added activities, okay, so you can eliminate the waste. So lastly, value stream mapping eliminates waste by providing a roadmap to find the non-value added activities or waste which can be eliminated from the process. So this is the use or help of value stream mapping. Next, one more tool, that is key performance indicators, KPI. Some more tool in manufacturing, that is key performance indicators, KPI. Okay, so check out here how KPI works. Okay, what KPI? That is key performance indicators. Okay, so just to check out here, engage, 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 engage. All these need to be engaged. Okay, that is key performance indicators. See here, you can say it is here, measure, innovate, propagate, strategize. Okay, see that. Okay, you should go for measuring, then innovate and propagate it and strategize. So metrics designed to track the progress towards the goal of the organization by assessing, analyzing, and tracking processes. Okay. So there are some key performing indicators. Just like in the process, we call it as bottlenecks. In the similar way, so there are some key performance indicators. So this basically KPI that is designed to track the progress towards the goals of the organization by assessing, analyzing, and tracking the processes. Okay, what are the points to be kept in or select in a key KPI? Because we have to select the key performance indicators. Okay, what are the points to be kept in mind? Okay, for selecting KPIs. Okay. Points to be kept in mind by selecting KPIs. Okay. So one is focus on the critical few. Measure the critical ones. Too many KPIs will lead to confusion. Okay. So if you're going to have so many performance indicators, then of course they're going to give confusion. So you should always go with the lesser. Yeah, sorry, I have got yeah. So it's very important that should focus only on the few KPIs. If you have more KPIs, leads to confusion. So measure the critical PIs only, of indicators only. Selected KPIs should drive toward your strategic intent. Yes, KPI are the part of the operation strategic plan. Okay, so whatever the KPI, that is key performance indicators you are going to choose, okay, they should drive towards your strategic intent. Okay, what is your intention? What is the intended to do? Okay, so what are the indicators you are going to choose? They should give that result, in fact. So the selected KPIs should drive toward your strategic intent. KPIs are relatable on all levels of the organization, such as production of units per hour or invoices processed per hour. So remember, when you're going to choose any indicators, KPIs, so they are relatable to all of the organization. Okay, you can't choose only one KPI that is for only one level. Okay, so because basically you should take into account the entire process. So what are the KPI you are going to choose should be applicable to all levels. Whether it may be something like production of units per hour, okay, or you can say the number of invoices processed per hour. Okay, so normally the invoice processing at the lower level and production of units at the middle level. So when you're going to choose any KPIs, should be applicable to all levels. Data for KPIs are valid. Data should be meaningful, timely, and reliable for sound management decision making. Okay, so when you're going to choose any KPIs, so that the whatever data you're going to collect should be reliable, because based on that data only you're going to choose KPI. So whatever data or information you're going to use for KPI should be valid. So that should be meaningful and timely. Remember, so when the process is going out of control, then of course we need some data to see that why that process is going wrong. So we should get the data in a timely manner and also reliable for sound management decision making. So for decision making, we need a meaningful data, timely available data, reliable data. Okay. And one more thing, lastly, that is ensure controllable KPIs are selected. Okay, if you're going to, there's sometimes you're going to choose such a indicators that you have no control over it. You can't. Okay, then what are you going to do with it? Okay, so it's very important that we're going to choose the KPIs, okay, which are controllable. What you measure must be controllable in order to obtain the strategic objective you desire. So it's very important to start only, not only saying that KPI is one is important to manufacturing, but also choosing KPI is also very important, because what data you're going to use KPI also matters lot here. Okay, so these points are very important. You go through once again, okay, all the points. Okay, what is the basic intention of this KPIs and how this KPI is going to help the organization in improving the profit or productivity. Okay, so normally, when you say lean manufacturing, people normally never going to talk about the KPI and they focus only on either Judoka, just-in-time, Izunka, Palestine mapping, just-in-time. Those things only they focus, but very less people are talking about the KPIs. So it's very important while choosing KPIs, these points should be taken care. That is, KPIs are relatable to all the levels and should drive towards strategic intent, and the data what you want to should be valid, and should choose the controllable KPIs. Okay, so select such that you can control to obtain the strategic objective you desire. Okay, so that's very important. And lastly, I want to say this point. That is, how does KPI? Yeah, KPI accounts payable process can be. This is an example. Right? We'll directly go for how this KPI helps. Okay, how does KPI helps the organization in improving profitability or productivity? Okay. So KPI helps in achieving the organizational goal. Organizations use KPI to assess, analyze, and track the performance of the process because you are intended to improve the performance of the organization or improve the productivity of the organization. So this KPI is used to assess, analyze, and track the performance. Okay, to assess, analyze, and track the performance. And it helps in driving the desired behavior. Train your employees to work in a KPI-driven environment to achieve the strategic objectives. Okay, so first of all, an employee should know about what is the use of KPIs and how to select the KPIs. So it helps in driving desired behavior. So train your employees to work in a KPI-driven environment. Okay, so you should provide environment such that the worker should be working in KPI-driven environment. So you should be able to identify that these are the key performance indicators. So once you know this, then very easy because select the performance indicators, then focus on those indicators only. So identifying the problem also really matters here. Okay, so train the employees to work in a KPI-driven environment to achieve the strategic objectives. And it helps in exposing and eliminating the waste. Okay, ultimate last point, of course, exposing, identifying, and eliminating the waste. KPI helps in keeping close eye on the production cycle, quality, waste, and downtime. Okay, so when you're going to focus on key performance indicators, okay, maybe a process or a quality control or waste identification, they are the performance indicators. So basically, it's going to expose or identify and eliminate the waste by keeping a close eye on the production cycle, quality, waste, and downtime. Okay, that's how this KPI is going to help the organization to improve the performance. Yeah, I will take next class. Remaining one or two tools are remaining. I will just take afterwards.